Hello and welcome to the Jolly Franchers YouTube channel. I am James Franch. I'm the pink Jolly Francher, the watermelon flavor. And today we are starting a series about how to make a side scroller and integrate it into Fungus so that you can talk to people or enter doors like in video games like Night in the Woods or Hollow Knight. This will be the first video in the series. We're going to have sort of a beginner's guide to coding. We're going to make a little player that walks around on some ground and can jump. This is how I learned to code, and it really opened my eyes to the things that you can do in Unity. Next week, I'll be teaching you how you can easily integrate this into Fungus. If you liked this video, or you liked our Nuzlocke run from 2 weeks ago, please like, comment, and subscribe on more videos you would like to see. Here's the video. So I have opened a blank scene here, and I have dragged in some art assets. You can find some free online. You can make them. I have some here of little characters. So I am just going to start by dragging in our player, which is this man with a bag on his head. And now I'm going to drag in a bit of ground for that player to stand on. These will be the two essential things for a side scroller: player and ground. So the very first thing I'm going to do is make sure the main camera is looking at them. So I'm just going to go ahead and reset the position of these two things, because I believe our camera starts at 0, 0. So once you have your player and your ground in the camera preview, you can tell what the camera preview is by either clicking on main camera and being in scene view. You get a little camera preview down there, or you can go to game and see your tiny character if you're me. If it's this tiny, you can change the orthographic projection size here in camera to something smaller, like 2. Wow, look at that detail. I am going to want things to collide with one another, because right now, if we start the scene, there's nothing happening. The player isn't falling to the ground, and even if they did, they would fall right through it because there's nothing telling it not to. So first thing you're going to do is you're going to go to your player, and instead of NPC sprite sheet _12, I'm going to name this lovingly player. And I am going to go down here to add component, and we are going to add the component rigid body 2D. You click on rigid body 2D, it pops up. Wowza. Something you're going to want to do is you're going to go ahead and want to open up constraints down here and freeze rotation on the Z-axis, which would make our player spin around and round sometimes when we apply forces. And I think we want mostly our player to stay upright, unless you want them to trip over and over down the stairs comedically. Then you would want to rotate them on the Z-axis. So if we start our game now that we've attached the rigid body, the player should freely fall, and they're gone. Bye-bye. You know, you could want that. You could want a free fall, and that's how you get it. You put no colliders on anything, and you let them go. But I am going to put colliders on things. So I'm going to go down to add component. Again, I'm going to type in collider, and I am going to put a capsule collider on my player, because that makes the edges nice and smooth, so that if you ran into like a set of stairs or something, you wouldn't like snag every single stair. So I'm going to go here to edit collider. I'm going to go back in scene view because I'm in game view and I can't see the collider. I'm going to click to really zoom in on this, and frankly, that's pretty good, and I'm not going to change it. Our player has a collider on it, but the ground also needs a collider. So I'm going to put a box collider 2D. Same thing. You go down here to add component. You type in box collider 2D. You click on it and it shows up. And I'm just going to press edit collider, but that is pretty much exactly what I want. So let's see what happens. Hopefully it has the expected result. It did. Wow. Did you see? Our player fell. Our player fell onto the cold white ground of heaven. I'm going to go ahead and type in ground here, or groud. I like that, and so I'm going to keep it. Our ground's name is officially groud. So just to illustrate two juicy things colliding with each other, I will raise our player up and we will watch them fall. Wow, scintillating experience. So now is when we get into needing to code in order to make our player move around. I assume most of you watching this video are here for fungus-related reasons and the narrative interaction that we will eventually get to, and thereby have not done a lot of coding. I will attach a video about how to download Visual Studio, which is the program we will be coding in, and how to make it work with Unity. In my experience, it wasn't very difficult. We've clicked on our player, we're going down here to add component, and I am going to go down here to the very bottom and click on New Script, and we are going to call this script player, and we are going to create and add, and voila, the player script has been added to our assets folder. Now we're going to double click on the player script and it should open up in Visual Studio. So we are here with and we need some information. We need the keys that we're going to press to move the player and perhaps make the player jump. So I am going to go ahead and make a public, you'll understand why I put public here in a second. I want a public key code variable, and I'm going to call that variable interaction keys. I promise if you don't understand the words I'm saying, but you just type this in and do as I do, then you will at least have a game that works, if not have a greater understanding of the way that Unity works. So I'm going to save this by pressing Command S, because if you don't save it, then nothing gonna happen when you go back into Unity. So if we go down to our player script, whoa, there's something called interaction keys here. Whoa, and it says size 0. I think this is going to be used for the interaction key only, because we're going to handle the controls to move around in a different way. So I'm just going to put in here that we want, you know, when you go up to someone you want to talk to, or you go up to a door, you press E and you'll go in there. Next, I am going to make a public float. A float, as you may know from Fungus variables, if you've watched my other videos, but a float is a variable that can be a floating point number, something like 0.1 or -2.1. But I'm going to call this float run speed. This will be a number that we use to tell the program how fast we want our player to move. I'm going to make a public float called jump speed. That basically does the same thing as run speed. I am going to need to get the rigid body that we just attached to our character. So I will make a private rigid body 2D, and I will call it my rigid body, which is pretty horrifying. Now, all these other things are public, meaning that when we go back into Unity, we'll set the values right here. You know, we'll type in fact, let me save this. Boom. Public things you can set here in the inspector. I'm just gonna set the run speed to 2 and the jump speed to, I'd set those because that's what I did before, but you can experiment with these things. This is a pretty slow run speed and a little jaunty jump speed. You can have whatever you want. But when you make a variable private, you can only access it within this script. For instance, I could set this to public. I saved it and I will wait for it to load. So as you can see, I could set my rigid body to public, and I could drag in the player game object that has the rigid body on it. This rigid body is what's giving us gravity. It's giving us sort of a physics simulation. And I'm dragging it into our script so that I can say, you know, when we press the left button, we want to apply some force that makes our player go left. So that's what I'm doing. But as you can see, we're going to have a bunch of things like this sitting on the player. Generally, it's best practice as things get really complicated to make something like this private. And in our start method, as you can see, start is called before the first frame update of the video game. So that just means when the player object exists, we are going to set my rigid body equal to, and we're going to get component. Remember, we added a component to our player previously. We're going to get component rigid body 2D. This works if the script is on the same game object that the component is on. I could put here private box collider 2D, and actually we are going to need one of these, so I'm just going to go ahead and put my feet collider. This will be for jumping later. Because we also have a box collider 2D component on our player game object here in the hierarchy, these are all components. We can do the exact same thing. We can say my feet collider equals get component, and then we're going to do this funny syntax. You can see that Visual Studios is helping me with the syntax. Actually, it's telling me put carets around whatever component you want to get and then end it with these parentheses. See, it's helping me down here too. Visual Studio is really good at helping. Now that we have our rigid body, we want to make sure when the player presses their arrow keys or WASD, the player is going to move. So I am going to make a method down here. I'm going to make a private method. You're going to type in private void, and you're not going to know why for a while, and that's okay. You do some parentheses, and then you're going to do curly brackets, and if you press enter right now, the curly brackets will appear like this, and they won't get in your way. So the first thing we want to do here is we want to create a variable. I named it delta x because in math terms, that means like change in the x value. The x value on a graph, I hate math, and you don't have to do a lot of math to code. It depends what you're coding. The delta x means the change in the x value. The x value on a graph is from left to right in layman's terms. In side-scroller terms, the x value may be -1 here, and it's +3 here. So we're creating a variable that every time this method is run, which we're actually going to put this method in update. And as you can see, update is called once per frame of the game. You have to put a semicolon after that, sorry. Every frame that the game runs, this update method will be called, meaning this run method will be called. And it's going to capture the change in the x value based on the horizontal arrow keys you press. And we're going to use that change in the x value, create a vector2, which is a type of variable that holds two values, an x value and a y value. And I'm going to name it player velocity. And I am going to set that equal to a new vector2. And for the first value, we are going to put our change in the x value. For our x value, we are going to put whatever the new x value changed to here. We're going to multiply that changed x value by our run speed, so that's how fast we'll go. And then for our y value, we want it to be equal to wherever our rigid body is, so that if we fall off a little block, it still knows where we are, and it will still move our x direction. You're going to put a semicolon over there to tell the computer that's it. And then down here, we are going to set the rigid body's velocity. We're going to actually tell the physics simulating object on our player, velocity. We're going to set the velocity to equal that variable that we just made, that vector2 variable. Whew. That took a lot of brain power. So I'm going to save this, and I am going to see if indeed we are moving. We're going to see if there are any errors. Okay, I'm going to play my game, and let's see. My God. I did it. So our player's moving now. It looks terrible unless you want your game to be about sort of a moving cube or a man who doesn't move his feet or a person who can levitate or a cool girl who's a sliding person. But in most cases, we don't want that. We're going to step into the animator window. We're going to make sure we click on the player object, and to begin animating the player, we are going to create an animator and an animation clip. Huzzah. I'm going to call this player run. Ha-cha-cha. You could have decided where to save that and be more organized than this, because this is terrible. And the animation for your player saves in here if you just do what I did. You probably want to put these into folders, like an organized person. So I'm going to move my project folder up here so I can look at my assets once again. You may have animated with me before. For this one, for player run, I'm going to use my man with a bag on his head. First thing I want him to do when I start running is to take a step. So I'm going to put this stepping animation here. If I move this a little bit out, and we go to our hierarchy and we double click the player, we can see he's stepping. And then next time I kind of just want that to happen over and over. Copy the step again, and I will put it equidistant. And now that's a walking person. If we press play right now, our person is walking. Now they don't turn around, they walk backwards if they're going to the right, and they don't stop walking when they're completely still, which is not what people do. So I'm going to create a new clip. I am going to call it player idle. Will just be a still bag-headed man. I'm just going to drag in 2 of them because I'm paranoid. So now in our animator, if you don't have an animator window up here, you can go up to Window, Animation, Animator, and click on that, and you'll get a brand new animator window. What I'm going to do is I'm going to create a new parameter, and this variable, this Boolean variable, as you can see, I clicked here and I created a bool parameter on this plus button here. I am going to double click on this, and I'm going to name this is running, because we want to check if our player is running or not. We want player idle to be the default state. So I'm going to right click on this or control click and set as layer default state. That means if we played the game now, our player would be standing still instead of running. So if our player is running, I'm going to right click on this or control click, and I'm going to make a transition, and I'm going to drag this sweet little line to player run. And I'm going to click on the arrow because for our transition, I'm going to add a condition here, and it actually fills it in for me. If running is true, then we want the player run animation to play. You see up here the has exit time. That means that even if our player is moving, there will be some exit time on the idle animation, and we don't want that. We want to immediately have it look like our player is running as soon as they're moving along the x-axis. And I'm also going to set the transition duration to 0. I don't know if that's actually necessary, but I am paranoid, I've already stated. I'm going to do the same thing from player run. I'm going to make a transition from player run to player idle. I'm going to go down here to conditions if you didn't see me do it before. I'm going to add a condition if running is false. The unfortunate thing, we did all that, and if we play the game, now the player is just going to be still. And when we move them, they're not going to do the running animation. So we need to make some big changes around here. And what we're going to do is we are gonna add an animator variable. We are going to have it be a private animator. Press enter for it to capitalize and understand what it is I'm talking about, and I'm gonna name it animator. And because it's private, as I stated before, we are going to want to make sure our script knows about it before the first frame update. And I'm just gonna do the same thing I've done before. Get component, animator, and I'm gonna add the bells and whistles that it asks for to the end of that. When we run is when we want to transition to the running state. I am going to put here animator dot set bool. It wants the string name of the bool, and I believe I named the bool is running. Strings you put in quotes is running. And then the second thing that animator.setBool wants is a value, true or false. So we want to somehow distill the fact that we're moving down to a true false. So we're going to use math, and we're going to get the absolute value of the rigid body's velocity on the x-axis. It doesn't like this because absolute value returns a float variable. I'm not good enough at math to have figured this out by myself. Luckily, you're watching this now. This is the solution that I eventually arrived at. basically when you use an is greater than operator, it returns a true or false value, which is what animator.setBool wants, a bool value for its second thing. And we want a bool value, like, are we running or aren't we? If so, make the animation play. And absolute value means that it will always return a positive number. So if our velocity is negative 9.8 because we're running to the left, it will return 9.8. And if our velocity is greater than math f.epsilon, which is a tiny floating point number like 0.00000001. So if it's greater than 0.00 repeating 1, then we know true, we are running. So let's go back and see if that works. Remember to save your script after you make a change, or else you will not see the change that you made to your script. Oh, wow, look at that. Wow, look at that. When we move our feet. When we stop moving our feet. We still have the problem that when we walk to the right, we walk backwards. So let's fix that. And then let's learn how to jump, and then maybe that's it for today. And then we'll get into the fungus side of life next time. We are going to make a new function. It's going to be a void called flip sprite, because when we walk to the right, we are going to want to flip the sprite. And when we walk to the left, we're going to want to flip it back. We are going to want to reference another component on our player object that you may not have even noticed was there. It's called sprite renderer, and it renders the picture of our player. So we want to access this component because we want to access a method in this component called flip x, which, as you can see up here, flips the player on the x-axis, which is what we want to happen. As you've guessed it, with things we've done before, we are going to add a private sprite renderer. Haha, it appeared. And we are going to name it sprite renderer, because we are uncreatively coding. And we are going to do the same little song and dance we've done here before. Sprite renderer equals get component. And we are going to put parentheses because it likes that. And we're going to end it with a semicolon because it likes that the most. Now we can reference our sprite renderer in order to access its flipX method. We're going to want a Boolean variable inside this method called player moves. If we want to get more specific, player moves on x-axis. We are going to make that equal to the exact same thing we did here. And actually, I'm going to copy paste it. Basically, we want the same information that we had before. So if player moves on x-axis, you might be familiar with an if statement from Fungus itself. If the player is moving on the x-axis, then sprite renderer.flipx, as I showed you before. Zach just cut a big section of this video where I forgot to add the flip sprite method into update. So if you make a method and it's supposed to be called once per frame in order to check if you should flip the sprite or not, you should put it in update. I want to check and see what the velocity is. If my player is moving, then I want to check if the velocity is greater than basically 0. This should be it. This is it. Wow. Wow, watch me flip. I'm flipping now. There's a little bit of a stutter, and that's probably because I didn't cut out my sprite sheet very well, and we're gonna check that out. You know, it's because I set the pivot to not be on the center, and so it's flipping from here, and it doesn't look so good. So I'm just going to go ahead and set these pivots of these two boxes to center, and then I think it's going to do a lot better. And we're going to go check. You may have not seen it, but I did. And now I'm inside the Earth because I need to reset my capsule collider. Voila! The sprite flips when we flips. And the first thing we're going to do is we're going to add another box collider 2D to our player. We are going to edit the collider, and this is just a little bitty feet collider. And we're gonna select is trigger here. We don't want this to collide with anything because it won't give us that smooth collision of our player. So when we check is trigger, it's not colliding with anything in the gravity type sense. It is only a trigger for the script to check if something is happening. And indeed, we are going to want to be checking when our player's feet leave the ground and when they touch the ground again. Because when our player leaves the ground, we don't want them to be able to jump again in midair unless you want a sweet double jump or infinite jump mechanic in your game. So let us create a new method called jump, parentheses, curly braces, enter. So I believe I had it get a box collider 2D already because I was looking ahead for my future self. But you want to put a private box collider 2D here. You want to get component box collider 2D and set it to my feet collider. And therefore here, I'm going to go ahead and call this method an update so I don't forget again. And we are going to say if my feet collider dot. So I'm going to go over here to my ground game object, and I am going to create a new layer, and I'm going to name it ground. And voila, here it is. And now any ground object that I make from here on out, I want to make sure to give it the layer type ground. If you jump into a wall or something, you don't maybe want to get your jump back, or you might want to get a wall jump, and so you might want to add a layer like wall. Depends what kind of game you are making. So I'm going to do if my feet collider is touching layers and layer mask dot get mask, and this is where I type in the name of my layer, which is lowercase ground, which was an interesting choice by me. When I type return here in the curly braces, wait, if equals false. If my feet collider is not touching the ground, then we want to stop this method. We want to return from this method, and thereby we will not jump. And I will now put the commands for jumping after this. So if we press the jump button, which will be input dot, get button down, which will trigger when you press down the space bar, which we can symbolize by typing in the string jump, which is in the input manager. If you press the jump button, then we want a vector2 because we want to get a y value. We're going to call this vector2 jump velocity, and this vector2 equals, and I'm going to be honest, I don't know why this is the syntax, but this is seemingly how you set a vector2. We don't want it to add any velocity on the x-axis when we jump, so I'm going to type 0f, 0 float. And then on the y-axis is going to be our long-awaited float jump speed. And semicolon after that, because now my rigid body, we're going to add this velocity to our rigid body, so it actually happens. My rigid body dot velocity plus equals. Plus equals is adding it onto whatever velocity we're already traveling at, so that when we jump and we're traveling to the side, we won't just stop on a dime and just go straight up and down with the x velocity we were already traveling with sideways as we jump. My rigid body dot velocity equals the vector2 we just created called jump velocity. I'm going to save it. Wow, I jumped to the absolute moon, but it works. I'm pressing it again. I'm pressing it in the air, and I don't seem to be jumping any higher than my initial jump. We are jumping, and if you'll remember again, the way we made this, we can change the jump speed here, but also perhaps I'm not heavy enough in my rigid body 2D. What if I make my mass 10? What'll happen then? The jump is still fairly extreme. So how I'm going to experiment with this is I'm going to minimize my game view, and I am going to go here to my mass. Maybe I'll make it 100. Surely that's not too heavy to leave the ground. Okay, it's not too heavy at all, and I feel a fool because I should just change the gravity scale. These are just fun things you can mess with now. Until next time, we come back to this side scroller and learn how to talk to someone using Fungus, integrating Fungus into this side scrolling world we've created. The gravity scale of 10 is too much, so I'm gonna make it 5. That's a nice, feels more fun, this jump. Not too big, not too small. The changes I just made are not going to save because I was in play mode. So once you exit play mode, make sure to save those changes. And that's it for this week. 2 weeks from now, because we release bi-weekly, we will cover how to integrate this side-scroller stuff that we just made into Fungus. You can talk to a person, you can enter a building, maybe pick up an item and put it in your inventory that we made a couple weeks ago. And that's it for now. We here at Jolly Ranchers love you. Please like, comment, subscribe. I have a podcast called Brothers Pym. You can find it on Apple iTunes. Listen, we tell stories. We play games and we tell stories as we play games. If you like this, then tell me so, and like and comment and subscribe again, and I'll say it again. And goodbye. Stay jolly.